June 9, 1944. 0615 hours. North of Cannes, France. Morning fog drifted over broken wheat fields and covered the Allied forward line in a pale sheet of light that blurred the horizon. The infantry of Baker Company waited behind shallow earthworks, rifles propped on sandbags, boots sinking into wet soil. Ahead of them stood a fortified German outpost made of reinforced concrete. The structure commanded the only road that passed through the sector. It covered every approach with interlocking machine gun fire. For 3 days the Allied advance stalled under its guns. Every attempt to flank or rush the position ended with bodies lying in open ground. The Germans designed the outpost to survive shrapnel and direct hits. Repeated bursts from light artillery chipped the surface but never reached the core. The walls were too thick. The angle of the structure deflected incoming fire. Each failure grew more costly. Private Arthur Jenkins watched these efforts with a quiet intensity. He stood beside the 6-pounder anti-tank gun that his crew operated, cleaning mud from the base plate with a rag. The weapon could knock out armored cars at distance, but its mount allowed only limited elevation control. On normal terrain that did not matter. Against a hardened concrete target that required a hit on a specific stress point, the lack of micro-adjustment made the gun unreliable. Jenkins understood that problem better than most. Before the war he worked as a civil engineer. He installed heavy machinery in factories. He set angles for bridge plates where a margin error of a few millimeters meant structural failure. His mind still measured land angles and load distribution even in combat. Captain Davies, the company commander, studied the outpost through field glasses. His jaw tightened each time machine gun bursts struck the ground near the forward trench. His map showed a narrow weak point along the right side of the outpost. Intelligence suggested a hairline flaw in the concrete where 2 layers had not bonded correctly. The flaw sat low on the wall. If an armor-piercing shell struck it at the correct angle, the internal pressure would spread through the weak seam and collapse part of the structure. The challenge was hitting it. The standard gun mount shifted slightly each time the crew fired. Sandbags placed under one leg compressed under recoil. The surface inch of mud behaved differently with temperature changes. These variables made precise fire impossible. Jenkins knew the flaw required repeat hits within a small radius. Without a stable elevation system they would never strike the same spot twice. Jenkins approached the captain and requested permission to attempt an improvised solution. He explained that the gun needed a dynamic support able to adjust elevation in tiny increments. He proposed using a partially filled steel water barrel under the rear of the mount. By changing the water level, the barrel would rise or fall in controlled movements. Water weight distributed evenly. Small changes produced predictable motion. It was a method he used in factories to level heavy plates. Davies listened but dismissed the idea. He saw it as unnecessary improvisation. Doctrine instructed the crew to adjust elevation manually. Doctrine insisted that precision came from experience and practice. Davies trusted the manual. He did not trust an engineer's trick involving water drums and improvised supports. He ordered Jenkins to return to normal duties. The next assault attempt lasted 8 minutes. Mortar rounds fell short. A squad tried to crawl forward but machine gun bursts cut them down before they reached the halfway point. Medics pulled 2 wounded men back through smoke and dust. One died minutes later. The other lay silent under a blanket. Jenkins watched the stretcher pass and felt anger rise. The outpost did not defeat them with superiority. It defeated them with a flaw in their setup. He knew they could overcome it. He walked back to the water supply truck, lifted a steel drum and rolled it toward the gun crew. The other gunners watched with curiosity. None stopped him. He filled the drum halfway and positioned it under the rear section of the 6-pounder mount. When Davies returned and saw the setup, his face hardened. He demanded an explanation. Jenkins kept his voice steady. He repeated the engineering logic. He described how water allowed micro-leveling of heavy machinery. He reminded the captain of the casualties. He refused to back down. The silence stretched as the captain weighed orders against desperation. Then he gave a short nod and allowed the test. Jenkins took command of the adjustments. He knelt beside the water drum. He used a long metal rod as a dip tool to check depth. Each centimeter change altered the elevation by a measurable degree. He communicated adjustments clearly. The crew aligned the gun with a marked reference point on the outpost wall. Jenkins studied the horizon and counted seconds between wind gusts. He instructed the crew to fire. The first round struck high. Jenkins adjusted the water level by a small amount. The second round hit lower. The crew noted the shift with quiet amazement. They fired again. The round landed within a meter of the flaw. Jenkins refined the water level again. The barrel rose a fraction. The fourth shot hit the wall directly on the weak seam. A small plume of dust rose from the point of impact. Jenkins asked for another round. The next shot hit nearly the same place. The dust plume was larger. The captain leaned forward with renewed focus. The crew reloaded. The Germans reacted with machine gun fire but could not pinpoint the gun through the fog. Jenkins maintained adjustments with disciplined concentration. Each shot landed closer to the desired zone. The concrete surface began to show visible cracking near the seam. Jenkins stayed beside the water drum while the crew prepared the next shell. He checked the depth with quick movements. He lifted the rod, watched the thin stream of water slide off the metal, and made a minor correction. He shifted his body weight to stabilize the drum. The gunner locked the sights on the crack forming along the lower section of the wall. The fog thinned enough for Jenkins to see the outline of the outpost more clearly. The fracture line grew with each round. He noted the dust pattern from the previous impact. The dust rose in a tighter plume. That meant the shell hit the correct vector and entered the damaged layer. He asked for confirmation from the loader. The man nodded and slid the next round into place. Captain Davies kept his binoculars pressed against his brow. He did not speak. He understood that any command might break the focus of the crew. Jenkins issued clear, short directions. The crew followed each one without hesitation. The fifth shot struck the same weakened point. A larger piece of concrete broke loose and rolled down the sloped front of the outpost. The fracture widened by a few more centimeters. Jenkins looked at the water again. He calculated the next adjustment. He added a small amount from his canteen. The surface inside the drum rippled. The mount shifted smoothly. German machine gunners inside the outpost changed their fire pattern. Their bursts swept the forward trench line. One round struck near Jenkins's boot. Dirt sprayed across his leg. Jenkins ignored the danger. He saw the wall giving way. Another 2 half steps in elevation would align the gun barrel with the lowest stress point. The next few hits would decide the outcome. He wiped sweat from his forehead with the back of his hand and repeated the calculation in his head. He instructed the gunner to hold steady for a moment. He observed the wind. The fog lifted enough to reveal the entire right side of the outpost. The crack now stretched almost 1 meter. He told the loader to stand ready. The sixth shot hit slightly lower than intended. It still struck the weakened seam. The sound changed. The impact produced a dull, fractured echo that indicated internal collapse. Dust blasted outward from the right corner of the structure. Jenkins kept his voice firm. They needed to maintain pattern. The crew adjusted for the next round. Jenkins used his rod again and checked the water depth. The precise elevation depended on that measurement. A runner sprinted toward the position. He carried a message from battalion command. Reports had reached the rear that Baker Company made progress against the outpost. Davies read the note quickly. Reinforcements were on standby. If a breach formed, infantry units would rush forward and clear the interior. Davies folded the message and returned his attention to the gun. He asked Jenkins for an estimate. Jenkins answered without taking his eyes off the wall. 3 more rounds. Davies approved and signaled nearby squads to prepare for movement. Men checked grenades and fixed bayonets. The tension on the line grew. Everyone understood the risk. A partial breach might create a deadly funnel. If the Germans held their positions, they could still cut down attacking troops. The success of the assault depended on Jenkins's precision. The loader slid the 7th round into the chamber. The gunner steadied his breathing. Jenkins placed a hand on the side of the drum. He felt the vibration from the previous shot. He waited for the ripples to settle and instructed the gunner to fire. The shell impacted half a meter from the ideal point. It struck on the edge of the fracture line. A shower of concrete chips burst outward. The crack widened, but not enough. Jenkins made a new calculation. He lowered the water level slightly. He measured twice to confirm the correction. The crew prepared the 8th round. Jenkins instructed them to wait for a brief lull in machine gun fire. He listened for the rhythm. The Germans reloaded after long bursts. He counted the seconds. He raised his hand. The crew fired. The 8th shot landed perfect. Dust blasted outward in a dense sheet. A section of the wall flexed inward. Jenkins heard a deep cracking sound that rolled across the field. It was the sound he waited for. The internal framework had taken critical damage. One more hit at the same elevation would collapse the section. Davies lowered his binoculars. His voice carried enough force to steady every man. Fire again. Jenkins checked the water level one last time. He added a few drops. The mount shifted by a small fraction. The crew loaded the 9th round. Jenkins aligned the elevation. He nodded to the gunner. The ninth shell struck the weakened point and released a violent fracture. The right corner of the outpost gave way. The wall split open. A chunk of concrete fell outward, sending a shock through the ground. Dust filled the air. The internal machine gun position collapsed. The German fire stopped completely. Davies shouted for the infantry to advance. Soldiers climbed from the trench and surged across the field. They ran low, rifles ready. The dust cloud covered their movement. Grenadiers reached the breach first and threw explosives into the interior. A muffled blast echoed from inside. Allied troops rushed in. Short bursts of rifle fire followed. Then silence. Reports came back within minutes. The outpost was secure. The surviving German soldiers surrendered. The machine gun crews were incapacitated by the collapse. The interior support beams had buckled. The structure no longer held defensive integrity. The infantry gathered at the base of the broken wall. They inspected the fracture. Men pointed at the impact marks and the collapsed concrete. They understood the significance. The breach did not come from luck. It came from repeated hits on the same stress point. It came from precision they had not achieved before. It came from the water barrel sitting under the mount of a gun that was never designed for such micro-adjustment. Jenkins walked toward the breach and examined the damage himself. The crack line matched the calculations he made earlier. The shells entered the interior layer and spread force across the flawed seam. The collapse unfolded exactly as expected from a structural perspective. Jenkins felt a quiet satisfaction. He had applied his civilian knowledge to solve a military problem that cost lives for 3 days. The method worked. The captured outpost smelled of dust, burned cordite, and shattered concrete. The interior was dim. Small shafts of sunlight pushed through gaps where walls once stood solid. Allied infantry moved through the rooms with caution. Their rifles stayed ready. Helmets brushed against hanging rebar. Jenkins stepped through the newly formed breach and studied everything with the eye of an engineer. He traced the collapsed section with his hand. The concrete failed along an internal seam that should never have existed. The German builders likely rushed construction. Poor bonding left a vulnerable layer. Artillery could not exploit it because the hits scattered. Only repeat impacts at the exact angle could unlock the weakness. The water barrel method provided that accuracy. A lieutenant from battalion arrived minutes later. He reviewed the scene, inspected the gun position, and took notes. He asked Captain Davies how Jenkins devised the system. Davies answered with a flat tone. Jenkins gave a proposal. Doctrine failed. They tried the proposal. It worked. The lieutenant nodded and told Jenkins he would include this in his report. He asked for a technical explanation. Jenkins described the principle. He explained how water weight allowed stable and predictable elevation changes. He avoided unnecessary detail. He gave the lieutenant the measurements he used. The lieutenant wrote everything down and moved on. Outside the outpost, the battlefield quieted. Medics treated wounded soldiers. Engineers placed markers for demolition teams who would later repurpose the structure. Jenkins walked back to the gun crew. The water drum sat under the mount. Ripples still moved on the surface. The crew gathered around him. Some clapped him on the shoulder. Others stared at the drum with disbelief. One asked how he learned that method. Jenkins said he used it to level machine plates in factories. Another asked if this could work on other guns. Jenkins said it depended on weight distribution and mount shape. He added that it could work for any weapon needing repeat precision within narrow elevation bands. Captain Davies called Jenkins over. Davies did not smile. He never smiled in combat. He asked Jenkins if the principle could scale. Jenkins said yes. Larger drums could support heavier guns. Multiple drums could create 3-point leveling. Davies nodded slowly. He told Jenkins that battalion command wanted diagrams. Jenkins agreed. He offered to draw them that evening. Davies dismissed him. The afternoon passed quietly. The sky turned bright blue. The ground dried. The infantry prepared new positions further ahead. Jenkins sat on an overturned ammunition crate and began sketching. He drew the water drum. He drew the mount. He added the angle measurements and noted the adjustments. He wrote a short explanation about weight distribution and fluid leveling. Some soldiers gathered to watch him work. They asked questions. Jenkins explained each point in clear terms. He told them how the drum stabilized the rear, how micro shifts came from small changes in water height, and how the method reduced recoil variation. A courier arrived at dusk. He carried orders from battalion command. Jenkins was to meet an engineering officer at dawn to brief him. Captain Davies read the orders and told Jenkins to rest. Jenkins nodded. He cleaned the gun with the crew and checked the mount again. The water drum remained in place. It would stay until someone replaced it with a standard support. The crew agreed to keep it exactly where it was. They trusted it now. It solved a problem that nearly killed them. Night settled across the field. The sky stayed clear. Stars appeared above the dark horizon. The men lit small lamps. Jenkins sat against a dirt wall and ate from a tin mess cup. He listened to the quiet conversations around him. Soldiers discussed the breach with excitement. They talked about how precise each hit looked. They mentioned how the machine gun fire stopped at the exact moment the wall failed. They spoke about Jenkins with a tone usually reserved for veterans who saved lives. Jenkins did not react. He kept his focus on the next day. At dawn he walked with Davies to a forward command post. An engineering officer waited for them. He introduced himself and asked Jenkins to explain the method in full detail. Jenkins delivered the explanation without hesitation. He drew additional diagrams on a map sheet. The officer asked about recoil effects. Jenkins explained how water absorbed minor vibration. The officer asked about limitations. Jenkins stated that cold weather could thicken the water and reduce responsiveness. He suggested adding warm water or using oil if available. The officer wrote everything down. He asked Jenkins for permission to send the technique to higher command. Jenkins agreed. The officer thanked him and left. Davies looked at Jenkins with a more measured expression. Davies admitted that he should have approved the idea earlier. He added that doctrine could not account for every situation. Jenkins nodded. He understood that commanders followed rules to maintain order. He also understood that rules sometimes failed. Davies placed a hand on Jenkins's shoulder. He told him that the innovation saved lives. The next days moved quickly. Allied forces pushed deeper toward Cannes. Resistance intensified. Machine gun nests and fortified pockets slowed progress. Jenkins and the gun crew marched with the unit. The water drum stayed with them. Whenever they set up the 6-pounder, Jenkins positioned the drum beneath the mount. The crew trusted the system. Other units noticed. Some officers from nearby companies approached Jenkins and asked him to explain the trick. He repeated the explanation each time. Soon several guns in the battalion had water drums under their mounts. Reports began circulating that other sectors started applying the method. Smaller drums supported anti-tank rifles on uneven ground. Larger drums helped stabilize light artillery pieces facing hardened positions. Some engineers modified the idea with metal boxes filled with water or sand. Others created wooden frames to hold drums in place. The method spread through necessity. It gave soldiers a way to adapt to terrain quickly. By the end of June, senior officers collected all field reports that mentioned the technique. They noted reduced ammunition waste, improved accuracy, and better performance against reinforced structures. They also noted that the method required no special equipment. The only materials needed were drums, water, and a few minutes of setup. This made the technique easy to adopt in active combat zones. Word of the method reached divisional headquarters. A technical liaison officer requested that Jenkins provide a full written explanation. Jenkins prepared the document over 2 evenings. He described the structural principles in simple terms. He explained how water weight distributed uniformly. He detailed how small volume adjustments produced predictable changes in elevation. He included hand-drawn diagrams that showed the angle shift line, recoil absorption pattern, and stable axis created by the drum. When the liaison officer reviewed the notes, he asked Jenkins if he had formal training in structural dynamics. Jenkins confirmed that he studied the subject before the war. The officer said the report would be forwarded to Corps Command for evaluation. In early July the unit faced another fortified German position. This one controlled a shallow ridge that overlooked 2 villages. The ridge had one approach route. The Germans fortified it with trenches, concrete firing points and overlapping fields of fire. The infantry could not advance without clearing the ridge. Standard artillery bombardments softened the defenses but failed to knock out the concrete firing points. The 6-pounder crews received orders to target the nearest firing point and remove it. Jenkins prepared the water drum without waiting for instructions. He positioned it under the mount and calibrated the depth. The crew aligned the gun with the target. Jenkins measured the slope, wind, and recoil vectors. The first round struck the front corner of the firing point. It chipped the concrete and exposed a lighter layer underneath. Jenkins saw the fracture and adjusted the drum. The second round hit lower and struck directly on the weakened layer. The sound changed. A hollow echo indicated internal compromise. Jenkins made another adjustment. The third round hit the seam and produced a visible crack. Infantry soldiers nearby paused to watch. They saw the accuracy and understood what would happen next. The fourth round hit the weakened crack. The wall collapsed. Dust rose. The German machine gun team inside the position fell silent. The infantry surged forward. They reached the ridge line and secured the position with minimal casualties. Officers praised the gun crew for exceptional precision. Jenkins gave credit to the method. More units adopted it. As Allied forces advanced through Normandy, the terrain varied. Some positions required elevation stabilization on steep inclines. Others needed micro-adjustment on soft ground. The water drum worked in all cases. It compensated for shifting soil. It reduced the effect of recoil on uneven terrain. It eliminated guesswork. Jenkins adapted the method for each environment. He taught other crews how to measure depth and calculate angle changes. He wrote short field notes that circulated informally among gun crews. These notes outlined quick steps. They became popular among units facing hardened targets. By late July, Battalion Command assigned Jenkins temporary duties as a technical advisor for anti-tank crews. He trained crews on water-supported elevation at rear positions. He demonstrated how water height changed barrel angle. He showed how to mark the inside of a drum for quick adjustments. Soldiers practiced by firing at marked boards. They improved accuracy rapidly. Officers noticed. They reported the results to divisional command. They recommended that the method become standard practice for improvised stabilization. The war moved forward. The unit received orders to push east. Jenkins returned to his crew. They traveled through damaged villages and open fields. They passed destroyed vehicles and collapsed buildings. Each new position presented a challenge. Jenkins applied the same principles. He supported the mount with a drum. He calculated angles. He guided the crew. The gun performed reliably. The crew trusted every instruction. In August, the unit reached an area with heavy German resistance. The enemy used reinforced bunkers that survived normal bombardment. Engineers studied the structures and found no obvious weak points. Jenkins reviewed the sketches and noticed subtle design flaws. He identified 2 possible stress zones. He marked them on a map. He explained how repeated hits at those exact points would collapse the roof. Officers approved the plan. Jenkins set up the water drum. The crew fired the first shell. It struck slightly above the target. Jenkins adjusted the drum by half a centimeter. The next round hit the marked point. The impact produced a thin dust trail. Jenkins adjusted again. The third round hit deeper. The concrete began to split. The crew continued firing. With each shot the crack grew. After 6 rounds the roof of the bunker caved in. The infantry moved in and secured the area. The method worked again. Reports about the accuracy reached senior command. They noted that the results matched those of stabilized artillery platforms. They recognized the ingenuity. They requested a formal engineering study. Jenkins contributed more documents. He described the method in structured terms. He explained hydraulic leveling principles, dynamic stabilization, and weight distribution. Engineers tested the method with different drum sizes. They confirmed the effectiveness. They recommended wider adoption. Despite the recognition, Jenkins kept his attention on the field. He focused on the safety of the crew. He maintained the drum. He checked the mount daily. He never let excitement distract him. He understood that precision in war mattered only when applied consistently. He kept refining the technique. He experimented with different water levels. He learned how temperature affected fluid behavior. He made small improvements. He shared them with the crew. In September the unit faced a difficult challenge. A German outpost controlled a narrow bridge crossing. The bridge was vital for supply movement. The Germans fortified the outpost with thick concrete and steel supports. Conventional gunfire bounced off the structure. Engineers suggested waiting for heavier artillery. Command disagreed. They could not delay. Jenkins inspected the outpost. He noticed a slight discoloration on the upper corner. That indicated a flaw in the casting process. He marked the angle on his notebook. He told the crew they would target that point. The gun crew positioned the weapon. Jenkins prepared the water drum and measured the initial elevation with care. He adjusted the depth several times. He aligned the barrel. The first round struck close but not perfect. He watched the dust pattern and corrected the angle. The second round hit the flaw. A short plume appeared. He continued adjusting. The third and fourth rounds hit the same zone. A crack started to form. The crew reloaded quickly. The fifth round widened the crack. The sixth round caused a structural shift. The corner of the outpost broke off. German fire stopped. The infantry crossed the bridge. They captured the position. Command officers noted the successful breach. They added it to the list of engagements where the water drum method proved decisive. The weeks that followed pushed the battalion east across weakened German lines. The terrain changed again. Forests replaced open fields. Villages appeared in clusters along dirt roads. The gun crew adapted to each new environment. Jenkins taught them how to find stable ground under thick leaves. He showed them how to compensate when tree roots lifted the mount unevenly. The water drum made the process simple. They could stabilize the mount even when placed on angled forest soil. Other gun crews observed and copied the method without hesitation. One afternoon the unit reached a cluster of farm buildings occupied by a German rearguard. The defenders used a stone barn as a firing point. The barn had thick walls reinforced with timber. Machine gun fire from the upper windows prevented Allied infantry from advancing. Engineers examined the structure. They could not find a weak point. Jenkins inspected the walls from the distance and noticed the mortar lines. The stones near the right window sat slightly uneven. That suggested stress concentrated on that area. He marked the approximate location and informed the crew that the target would require several round impacts at the same elevation. The gun crew positioned the 6-pounder behind a small ditch. Jenkins lifted the water drum and placed it beneath the rear of the mount. He checked the depth with calm precision. The wind moved through the trees. He watched the direction. He made calculations. The crew loaded the first round. The gunner aligned the sights. Jenkins instructed them to fire. The first shot struck the wall slightly above the target. The stones shifted. Jenkins corrected the water level. The second shot hit lower and carved a small cavity into the mortar. Dust fell from the window. German fire intensified. Jenkins ignored it. He measured again. The crew prepared the next round. The third shot struck the exact point. The effect was immediate. A crack appeared from the corner of the window frame. The crack widened after the fourth shot. The wall section sagged. The soldiers inside the barn tried to relocate their machine gun. The fifth shot hit the weakened cavity. The entire structure around the window collapsed. The machine gun team was neutralized. Infantry swept forward and secured the farm buildings. They advanced with fewer casualties than expected. Officers noted that the accuracy of the 6-pounder eliminated a dangerous firing point. Jenkins and the crew moved on to the next sector. As the battalion pressed forward, supply officers began requesting extra drums. The drums became part of the standard packing list for gun crews. The method no longer belonged to Jenkins alone. It became a battlefield practice. It spread through whispers, field notes, and demonstrations. Command units noticed a rise in hit consistency. They noticed reduced ammunition use. They approved a short field bulletin. The bulletin described an improvised leveling support using water drums. It referenced multiple engagements. It did not mention Jenkins by name. Field bulletins rarely credited individuals. They focused on procedure. The unit entered deeper German territory by mid-October. Weather grew colder. Rain turned roads into mud. The water drum reacted differently in cold conditions. The water inside thickened slightly. Adjustments became slower. Jenkins adapted by using heated water when available. He informed other gun crews to do the same. They followed his advice. The adjustments regained precision. In one engagement the battalion needed to neutralize an enemy mortar pit on a raised slope. The pit was protected by sandbags and a partial concrete shield. The shield covered the front. It deflected small arms fire completely. Mortar fire from the pit landed on Allied troops trying to advance. Jenkins analyzed the slope. The shield had a lower corner that sagged slightly. He identified that as the structural weak point. The gun crew positioned the 6-pounder. Jenkins set the drum. He adjusted water depth slowly. The first round hit the shield and chipped the lower edge. The second round pushed deeper. The third round cracked the weakened corner. The fourth round caused the entire lower support to fail. The shield collapsed. The mortar team retreated. Infantry captured the pit without delay. By late autumn Jenkins carried a small notebook that contained measurements for different terrain types. He filled several pages with angle correction notes, recoil compensation ranges, and water depth guidelines for different mount weights. Officers occasionally borrowed the notebook. They copied pages. They returned it with added comments. The notebook became an unofficial field manual. In November the battalion approached a critical junction. The Germans fortified a stone toll building with reinforced walls, firing ports, and sandbag protection. The building overlooked 3 roads and a railway. Heavy artillery was too far away to assist. Infantry could not approach without casualties. Command ordered anti-tank guns to weaken the structure. Jenkins studied the toll building from cover. He observed the wall patterns. He identified a horizontal seam where two stone layers met. The seam sat low and formed a potential fracture line. He marked the point on a map. The crew placed the gun behind a damaged cart. Jenkins positioned the water drum. He verified the stability. The crew loaded the first round. The shot hit near the seam. Dust lifted. Jenkins adjusted the water level. The gun fired again. The second shot hit closer. The third round struck the seam directly. The fourth hit the same spot. The wall cracked. German fire intensified in panic. Jenkins kept adjusting. The fifth round widened the fracture. The sixth round broke a section of the wall. Infantry ran forward, threw grenades inside, and neutralized the defenders. The junction opened. Later that evening, divisional engineers visited the position. They studied the impact marks. They asked the gun crew about the method. The crew pointed at Jenkins. He explained everything again. The engineers took notes and left. They added the technique to their design notes. Jenkins returned to the crew and resumed maintenance work. Winter approached. Snow fell on the fields. The water drum froze during one night. Jenkins broke the ice with the dip rod. He poured warm water inside. He insulated the drum with cloth. Adjustments became slower but still reliable. Gun crews in nearby sectors used oil instead of water. They used sand mixed with small stones. They improvised solutions based on his original method. Through December, the battalion advanced cautiously. German resistance increased. Each day required careful movement. Jenkins and the crew remained consistent. They fired with accuracy. They saved ammunition. They reduced casualties. Their reputation grew. By January, the battalion crossed into regions with heavy snowfall. Fields turned white. Trees bent under the weight of ice. The ground stayed frozen through the day. Gun crews struggled to stabilize mounts on hard surfaces. The water drum behaved differently in freezing temperatures. Jenkins adapted again. He instructed crews to fill the drums with a mixture of warm water and oil. The mixture slowed freezing and allowed smoother elevation shifts. Crews followed the advice and maintained accuracy even in severe cold. In one engagement, the unit faced a reinforced blockhouse at the edge of a forest road. The blockhouse used overlapping steel plates, concrete, and timber supports. Machine guns fired from narrow slits. Allied infantry could not approach. Engineers tried to identify weak points. Snow covered most details. Jenkins examined the structure through binoculars. He noticed a slight downward dip on the left corner. That indicated uneven load distribution. He told the crew to target that corner. They set up the gun behind a snowbank. Jenkins placed the drum under the mount. The cold made the drum rigid. The mixture inside moved slowly. Jenkins measured the depth with extra care. The first round struck slightly high. He adjusted with patience. The second round hit closer. The third round struck the dip directly. A thin crack appeared on the steel-reinforced surface. The fourth round widened the crack. The fifth round forced the corner to collapse inward. The blockhouse weakened. Infantry stormed the structure and secured it. Officers credited the accuracy of the 6-pounder. Snow continued to fall through February. The battalion advanced town by town. German forces retreated slowly, using fortified buildings as temporary strongpoints. The gun crew faced several such positions. Jenkins applied the same method each time. The water drum became so familiar that the men carried it with the same care as ammunition cases. They cleaned it. They protected it. They insulated it at night. It was no longer an improvised object. It became a tool essential for survival. In one village, the Germans fortified an old church tower. They used it as an observation post. Mortar crews relied on the tower to correct fire. The tower had thick stone walls. Engineers said it would take heavy artillery to bring it down. Command asked for test fire from the 6-pounder. Jenkins observed the tower. He found a faint vertical line on the east side. It marked a seam between old masonry and a later repair job. That seam created a weak zone. The crew positioned the gun at the end of a narrow street. Jenkins set the drum. He measured the angle 3 times. The first round hit to the left of the seam. The second struck the seam and left a fresh crack. The third deepened the crack. The fourth round split the stone. The tower leaned. The fifth round forced it to collapse on its own weight. The observation post was destroyed. Mortar fire ceased. Infantry advanced. The gun crew earned strong respect from the troops. Soldiers often walked past the 6-pounder and tapped the water drum as if it held good fortune. Jenkins never encouraged superstition. He explained that the drum worked because of physics and consistency. Soldiers listened, but to them the drum symbolized safety. They saw the results. They saw reduced casualties. They trusted the method more than any manual. Throughout March the battalion continued its push. The Germans fought stubbornly but lacked resources. They fortified bridges, mills, barns, and road checkpoints. Jenkins faced each target with the same systematic approach. He studied structural flaws. He calculated angles. He adjusted the drum. The gun fired with precision. In one battle the enemy used a 2-story brick building as a firing point. Jenkins spotted an uneven foundation line. 6 rounds destroyed the entire left corner. The building collapsed inward. Infantry captured the survivors inside. Command staff began referencing the method in briefings. They called it fluid elevation stabilization. They used diagrams based on Jenkins's notes. They instructed new crews to use drums when facing fortified targets. They drafted simplified explanations for recruits. They identified the method as a low-resource solution with high battlefield value. Despite the wide recognition, Jenkins remained with the gun crew. He refused offers to move to a rear training unit. He preferred working directly with the men. He believed the method mattered only if applied accurately in real conditions. He continued refining small details. He experimented with drum height. He tested different fluids. He found that colder temperatures required deeper water levels. He shared these findings with other crews. In April the battalion reached a river crossing guarded by a reinforced bunker. The bunker stood on a concrete platform that overlooked the water. The platform sloped slightly downward toward the river. That slope created tension on the right underside of the bunker. Jenkins saw it immediately. He pointed out the stress zone. The gun crew set the drum. They fired the first round. It hit the platform. The second round struck closer. The third round hit the underside right at the stress point. A crack ran along the base. The fourth round deepened the crack. The fifth caused the concrete to fracture. The bunker slipped. It fell sideways into the river. Infantry captured the crossing. The brigade commander visited the position himself. He asked Jenkins to explain the method. Jenkins did. The commander listened without interruption. He thanked Jenkins directly. That was rare for senior officers. By May the battalion neared the end of its campaign. German resistance weakened. Surrenders increased. Positions that once required careful breaching now fell quickly. Yet the gun crew maintained discipline. They treated each engagement with precision. They kept the drum ready. One evening the unit rested near a captured warehouse. Jenkins sat with the crew and sharpened tools. A lieutenant approached and handed him a message from divisional headquarters. The message stated that Corps Command officially recognized the water drum elevation method as a recommended field procedure for all anti-tank guns and light artillery facing fortified targets. It also noted that reports credited the method with reducing ammunition waste and lowering infantry casualties. The message ended with a brief line. The method originated from field innovation by Private Arthur Jenkins. The crew read the message and congratulated him. Jenkins nodded but kept his tone steady. He said the method mattered because it saved lives, not because it gained attention. The crew agreed. They prepared their equipment for the next day. The war neared its close. Yet the battalion still faced occasional resistance. Jenkins continued using the drum whenever precision mattered. He trusted the method. The crew trusted him. When the war ended, Jenkins returned home with little ceremony. He stepped off the transport ship in a quiet port. No reporters waited. No officers greeted him. He carried a single duffel bag and the same calm expression he held during the campaign. He walked through the small town where he grew up. Shops reopened. Families gathered. People spoke about victory, rationing, and the future. Few asked about the details of his service. He took a job at a construction firm that handled bridge repair and industrial installation. The work felt familiar. The machines reminded him of the gun mount. The steel plates reminded him of the concrete seams he studied in France. He kept his wartime notebook in a drawer. It held diagrams, water depth notes, and angle corrections. He never showed it to anyone at work. He used the principles quietly when setting precision levels for heavy equipment. Jenkins rarely talked about the water drum method. When neighbors asked about the war, he mentioned his crew, the long marches, and the cold nights. He did not mention that his idea breached multiple fortifications. He felt that the credit belonged to the men who fired the gun, carried the ammunition, and advanced through enemy fire. Years passed. Military historians published reports on improvised battlefield techniques. Some documents referenced the stabilization method used by anti-tank crews in Normandy. They described water-supported leveling as a field innovation. They did not mention the name of the soldier who created it. Jenkins read one of those reports by chance. He closed the book gently and placed it on a shelf. He felt no frustration. He knew that battlefield ideas spread fast. Names faded. Results stayed. He attended a reunion with his old unit several years later. The men recognized him immediately. They spoke about the outpost, the ridge, the barn, and the river crossing. They remembered the drum under the mount. They remembered how each shot landed exactly where it needed to. They told him that the method saved them more than once. Jenkins listened quietly. He thanked them. He said the crew made the idea work. As the night ended, one of the gunners approached him privately. He said that the method gave them confidence when everything else failed. He said that it kept them alive. Jenkins nodded. He placed a hand on the man's shoulder. He said that survival was the only measure that mattered. Jenkins lived the rest of his life in steady routine. He worked, repaired machines, and kept his tools clean. He saved his wartime notebook until old age. Near the end of his life he placed it in a small box along with his service medals. He left no letter. He left no explanation. He simply preserved the record of an idea that came from necessity and precision. The war ended long before he passed, but the method he created stayed in military manuals for years. It remained one of many quiet innovations born from pressure, risk, and the need to protect the lives of others. That was enough for him.